Good morning, everyone. So, today we are starting from sulfonation of benzene. That is where we end in our last class. So, for sulfonation of benzene, we are using SO3 as a electrophile, and we get benzene sulfonic acid and water also. For this purpose, benzene react with concentrated sulfuric acid, that is H2SO4. Now we have to learn how dissociation happened in H2SO4, that is sulfuric acid, and we get SO3 as a electrophile, not SO3H as a electrophile. So I will explain all these things one by one. First of all, if we assume that SO3H act as a electrophile, this SO3H, if we are taking this one is our electrophile, then what is the problem? If you see that after fusion in H2SO4, if SO3 is a electrophile, then OH minus, this OH minus act as a nucleophile, and this one, this OH minus is a very reliable relevant functional group, and this one also try to attach with benzene by nucleophilic substitution reaction, because in benzene there is also fusion occur, and there is a possibility to this thing happen, means this nucleophilic substitution reaction can easily take place in benzene, but we don't want this thing will happen. We need one and only sulfonation take place. Now you have to see how SO3 is prepared and how dissociation will occur in H2SO4, that is our sulfuric acid. For that we go for its mechanism. Okay, so first point for mechanism, that is generation of electrophile. So in this step we are taking 2 moles of concentrated H2SO4, that is sulfuric acid, so that the dissociation is happened in between these 2 moles of H2SO4, that is 1 mole from H2SO4, another 1 mole for H2SO4, instead of single one. So as I just show you in my previous slide, only 1 mole of H2SO4 is used for dissociation and for generating the electrophile. Okay, so instead of that we are using 2 moles of H2SO4. Now what will happen? A thermal dissociation will take place because it's a concentrated acid. Now we get different ionic species for thermal dissociation of 2 moles of H2SO4. So we get different ionic species like H3O plus, then HSO4 minus, and also SO3. So this HSO4 minus, it's a nucleophilic, and this one attached with our old electrophile, that is H plus. So this one will see in our third step, and SO3 act as a electrophile. So this will attack to the benzene. Now I know that you have a question in your mind, that is, what about H3O plus? This one seems like a electrophile also. Yes, it's true. This one also a electrophile, but not better than SO3. not better than SO3. But why? I just explain it later. But this H3O plus also take part in the reaction as a electrophile. We will see it later. Now we go for our next step, that is attack of electrophile. So as we know what will going to be happen. So here is our benzene. Now fusion is happening in benzene. So this electron is moving from one side to another in presence of SO3, that is our electrophile. But why SO3 is more better? So first of all, SO3 is nothing but sulfur trioxide and it's a polar electrophile. So if you see its Lewis structure, then you easily understood why this one is more better than any other electrophile. It's a polar molecule with a fair amount of positive charge on the sulfur atom, and it is highly attracted to the ring electrons. Transfer of hydrogen to the negative oxygen. So this type of intermediate we get, and also we can draw like this hybrid structure. So that's all about our second step, that is attack of electrophile. Understood? Okay. Now comes for our last step, that is removal of old electrophile. So this is our intermediate. There is a hydrogen atom which will remove from the ring by donating its electron to this carbon atom and leave as a electrophile. Now we having HSO4 minus in our reaction. So by combination of these two different species, we get 1 mole of H2SO4, that is our sulfuric acid, in return finally. And we also restore our benzene aromaticity. See, we have lost our one of our pi bond, but at the end it will restore again. So we get our aromaticity of benzene ring. Okay, now just we have to neutralize this thing, because it carrying one electron extra with it. So we have to just neutralize this extra electron by using another electrophile, that is H3O plus. We have already used our SO3 as a electrophile first time because it's a polar electrophile. So this one will take part in first attempt. After that, the remaining electrons which have to neutralize by using another electrophile, because electrophile wants more amount of electrons because they are electron loving. So we can easily neutralize this portion by help of an electrophile. So here is our another electrophile, that is H3O plus, which will already present in our reaction process. So by exchanging ionic deficiency, we get benzene sulfonic acid final, and also get water molecule. So this is all about sulfonation of benzene. Okay, understood? Now we go for our next topic, that is nitration of benzene. So for nitration of benzene, we are using NO2 plus, that is our electrophile for nitration of benzene. So in nitration of benzene, same thing will happen. Here is our benzene. It will react with concentrated HNO3 in presence of another acid, that is concentrated H2SO4, that is sulfuric acid, and finally we get our desirable product, that is nitrobenzene, and along with water molecule. So this H2SO4 act as a catalyst in this reaction, that is nitration of benzene. So we have to see that how this HNO3 is dissociated and prepare NO2 electrophile. So if we study Lewis structure, then it is easy for understood air oxygen atom having lone pair, and due to electron negativity, this lone pair also attract more electrons from nitrogen, means nitrogens having also lone pair with it. Okay, so this lone pair is also attracted by this oxygen molecule, and finally we get our NO2 plus, and this OH becomes minus negative charge, like this. But why this thing will happen, means this is our NO2 as the electrophile, but why this will be happen? This will happen in presence of H2SO4. This one is a catalyst in this reaction. So we finally get our electrophile by dissociation process, like this. So here it is our NO2 plus. So this will happen because of H2SO4. It conduct the protonation of this OH portion. This OH portion, it will be protonated in presence of H2SO4. Okay, so let's see the mechanism, how it will generate our electrophile. So first step, that is generation of electrophile. So here is our HNO3, it's a concentrated one, and here it is our H2SO4, this one also concentrated. So thermal dissociation will be occur, both are concentrated. So we can draw like this structures also instead of the molecular formula. For HNO3 the structure like this, and for H2SO4 structure like this. Okay, so this oxygen, so here is the position where dissociation will take place. So this oxygen molecule having its lone pairs with it, so dissociation is easily occur in this place. So in our H2SO4 will also dissociated in same manner. So this part will be dissociated with different charges, with one is positively charged, that is we get our small electrophile, that is H plus. Okay, and remaining part, the whole complex will become HSO4 minus, it also a nucleophile. So this H plus will take part for protonation, or protonation, it go for protonation of this OH group. So finally we get different ionic species like HSO4 minus, remaining part of this H2SO4, and H, this H plus, this H plus will go for protonation of this OH molecule, and it will try to attach with it. Okay, like this. This oxygen along with withdrawing electrons from nitrogen, so it will attach to the oxygen molecule, and also it need one, at least one electron. So this one means oxygen will get electrons from lone pair of nitrogen, so it will taking the electrons from it, and it will remove as water, that is H2O. So this will remove from the reaction, and the remaining part, that is NO2 plus, that is act. Finally we get our electrophile, like this. Okay. Understood? So this is all about our first step, that is generation of electrophile. Next one is attack of electrophile. So this is our second step. So this one as same as all the previous reaction like chlorination, bromination, sulfonation, etc. So I am not explaining this in this moment because same thing will happen. So you just see it. So here is our electrophile comes for attack, it will attack and we get some intermediate structure like this. So it's an intermediate structure. Okay, fine. So finally we have come for our last step, that is removal of old electrophile. So again same thing will happening here. So after completing the step removal of old electrophile, react with HSO4 minus. By combination of two different ions we get H2SO4 in return. So this H2SO4 act as a catalyst, so we get our H2SO4 back again as same format, and with it we finally get our desirable product, that is nitrobenzene. So this all about nitration of benzene. So we just completed our different halogenation like iodination, bromination, chlorination. Okay, after that we completing our sulfonation and nitration also. So you find that all whatever mechanism you go for, it's nitration or sulfonation or maybe chlorination, we have to do three similar steps. First one is generation of electrophile, second one is attack of electrophile, and the last one is removal of old electrophile. On the basis of this three steps, we finally get our desirable product. Whatever we are doing, it may be nitration, maybe sulfonation, or maybe halogenation. Okay, understood? So for today's class, that is enough. So thank you everyone.